Well, it all started with the reunited experience with the Gysi paintings, where we learned that we could do a virtual rejuvenation of paintings painted in the late medieval, very early Renaissance in Italy.
You can think of a digital image as a large matrix that is composed of certain numbers. And in a digital image, there's this smallest unit called pixel, and each pixel can be represented as like a three-dimensional vector because each pixel has red, green, and blue value, and by mixing different proportions of those three values, you get a particular color. Although this project started out as an art restoration project that had more to do with processing digital images and programming, what's underneath the program that is written to restore this painting has a lot to do with linear algebra.
It made sense for the Math 212 students to work on this because it was an interesting project and it required mathematics skills that were at the level of mathematics that they were learning in 212.
In 212, a lot of students were asking for projects. There was COVID, a lot of extra time. And so Professor Dovishis had this idea that, hey, there's still a lot of work to do with this restoration, a lot of room to explore that. And a lot of students in this 212 multivariable calculus class that are interested to learn things. It felt like a really great combination. The 212 students get to apply a little bit of the knowledge. We do sort of mathematical modeling and a lot of programming things. So they get to apply that and learn some maybe new things related to image processing in kind of a fun way by getting to see the results of these restoration projects.
Several students from my sections and other sections said, was there something that may be related to class that they could do as a project? It turns out that the image restoration, the mathematical ideas there, have to do also with basic mathematics, more linear algebra, but that has to do with the fact that colors are represented by red, green, and blue components, and so you can view the color of a pixel as something that you present in three-dimensional space.
There's all these cracks in the paintings, and say we want to remove these cracks in some reasonable way. We have to kind of think, how would we go about doing that? And I think math starts to get used when you think about, okay, maybe you first have to detect the cracks, and then you have to next kind of fill them in, cover them in.
Recoloring or changing a color spectrum is a transformation in a three-dimensional space. What the experience with the Math 212 students has shown us that it is feasible for students to learn those tools and then apply them and get good results.
This painting has discoloration and a lot of cracks. And so the goal was to restore it to its original form. And this is very subjective. We're not restoring the physical painting. This would be a digital version. And that was the goal, to have this digital sample or digital version. When you're walking through the museum, you could see it.
I definitely did not really think about, how math could correspond with color, how it could correspond with art. And now I know, not only is this just one painting, but it can open up an avenue for a lot more conservation in the future using this similar math techniques and computer science techniques.
That's broadened my view of math rather than being such a limited view of, okay, we're just, calculating or just learning math for learning math. It really has so much utility outside, and math is everywhere. So
through this project, I realized that making digital products to be displayed in museums is very meaningful, because for me it's a way to make museums more inclusive and more interesting to people who may not necessarily have knowledge in our history or history in general. I can't imagine myself doing anything similar if I'd gone to a school that is not Duke.